All right, welcome back to another chemistry video. Today is going to be pretty straightforward. I'm going to be going over how to name lots of different chemical compounds. So the core thing you need to know to name a chemical compound is to know what type of bond is holding the atoms together. Because the naming conventions are going to be different based on whether we're dealing with ionic bonds or covalent bonds. I'm going to start with ionic compounds today. And let's look at our first example. We have one atom of sodium and one atom of chlorine. I know that sodium is a metal and chlorine is a nonmetal. So right off the bat, that could tell me that this is an ionic compound, because this is always going to give me an ionic compound, a metal and a nonmetal. Now, the naming conventions are pretty straightforward. We're going to write the name of our first atom, which is sodium. And then for the name of our nonmetal, we're going to change its ending to an "ide." So instead of chlorine, we get chloride. And that's going to be our suffix that we use at the end of our nonmetal name. Moving on to our second example, same rules apply. The name of our metal is magnesium. And we have chlorine again, so this is a chloride. It doesn't matter that we have two chlorine atoms in this example. The subscripts, or the number of atoms that we have, will only affect the name of the compound in our covalent examples. So we're not there yet, so we can ignore that for now. And similarly, in our third example, I have two atoms of potassium, but still I'm going to call it potassium oxide. So oxygen is a little bit different, right? Because for chlorine, we just have to change the very end to chloride. But for oxygen, we kind of have to take off this entire piece back here and turn it into oxide. Finally, last example down here, we have iron and bromine, but there is something special about iron, and that it is multivalent. And what that means is it can have a couple of different charges depending on what atom it's bonded to. So if we go back to our first example, if I wanted to write out the ionic charges for my ions, I know that sodium always gives away one electron to become positive, and chlorine always gains one electron to become negative. So we'd have a charge of +1 on the sodium and a charge of -1 on the chlorine. However, for iron, there's actually two options. So if you look up iron on a periodic table, often you'll see a 2+ and a 3+ beside. And what this means is that it can either have a charge of +2 or a charge of +3. So in order to name this compound properly, we actually need to figure out what the charge on iron is. Bromine always has a charge of -1, and I have 3 bromines. So that means that overall, I have a charge of -3 here. And since I only have one iron, it must have a charge of +3 to balance out the negative charge. So when I'm going to write the name of this compound, I'm going to be writing iron 3 in Roman numerals, then bromide. So this is only necessary for multivalent metals. And that'll usually be transition metals, the metals that you kind of see in the middle of the periodic table. Okay, moving on to covalent compounds. And these naming rules are going to be for binary covalent compounds, meaning it's compounds that are dealing with only 2 elements. We won't be dealing with anything super complex like some of the things you'll see in grade 12 organic chemistry. So covalent compounds are going to ask you to use the prefixes here. And these prefixes represent just the numbers from 1 to 10. And we're going to use them to show how many atoms we have in a certain compound. Let's use our first compound as an example, good old H2O or water. If we want it to be really fancy, we could call it dihydrogen monoxide. So I've used the di prefix for hydrogen because I have 2 of those, and I've used the mono prefix for oxygen because I have 1 oxygen atom. In our second example, we have 1 carbon atom and 1 sulfur atom. However, I'm only going to use the prefix on my second atom, right? So if we only have 1 atom at the beginning, we don't have to mark it with the mono. So we just say carbon monosulfide. And you'll notice that we are still using the same suffix that we were using back here. So what we've added in this covalent scenario are these prefixes for the number of atoms. That's the main difference. Going down to our third example, again, just 1 atom at the beginning. So we're just going to write bromine. And I've got 5 fluorine atoms. So if I want to represent the number 5, I need to use the prefix penta. So this will be bromine pentafluoride. Last one, we do have more than 1 atom at the beginning here. So I do need a prefix dinitrogen pentoxide. Again, oxygen is a little bit strange. There will be some slight variations when you add prefixes and suffixes. So instead of writing pentaoxide, it's just pentoxide. So there will be some slight changes for oxygen. Okay, that is the basics for ionic and covalent compounds, but things do get a little bit more complicated, but I'm sure you'll be able to follow along. First thing I want to add to this is the idea of polyatomic ions. And all a polyatomic ion is more than 1 atom has come together to form an ion. So if I look at the first example here of NO3, this is called nitrate. And this entire cluster of atoms has a charge of -1. So I wouldn't call this nitrogen trioxide because that would have a charge of 0. It wouldn't be an ion, it would be a covalent compound. Because I've got this overall charge, we would call it a nitrate, and it's a polyatomic ion. Naming for polyatomic ions is super simple. We're just going to call it what it is. So usually on like a test, teachers will give you a list of the most common polyatomic ions. So I don't think you'll have to memorize all of them, but it is good to know the most common ones, like the ones over here. Let's do some examples here. So for NO3, which is a nitrate, I could write NaNO3, right? Because nitrate has a charge of -1, sodium has a charge of +1 as an ion, so I can make an ionic compound here. And I would just call this sodium nitrate. Very straightforward. What about this one down here? This is a hydroxide ion. Now it's got a different name. Most of them are going to use kind of an 8 suffix, but not to worry. the naming conventions are the same. We've got sodium, we've got hydroxide, so this is just sodium hydroxide. All right. One more thing here. We've got something called hydrates. And all a hydrate is it's going to be a traditional compound. So in this example, we have cobalt and chlorine coming together to form an ionic compound. And we have 5 molecules of water, or H2O, attached to this ionic compound. So before I look at the hydrate section, which is the water section, let's see if we can just name this ionic compound here. Cobalt is a transition metal, so we are going to have to specify what charge is on it. Chlorine has a charge of -1, and we have 2 chlorines. So we've got an overall charge of -2 on this side. That means cobalt needs to have a charge of +2 to balance things out. So I would say cobalt 2 chloride. And for the hydrate portion, I'm just going to use the usual prefixes. So I've got 5 molecules of water. I'm going to write penta and then hydrate. So if you see a compound with this ending of a dot and some molecules of water, don't worry too much. Try to name the first half of the compound and then add the hydrate ending based on how many molecules of water you have. Okay, we've done a lot already. Let's see if we can summarize things with some practice. First one right here, carbon and chlorine. I know right off the bat this is a covalent compound because we have 2 nonmetals. And I've only got 1 carbon, so I don't need a prefix for that. This is going to be carbon tetrachloride. Okay, moving on. Here we have copper, which is a metal, and nitrate, which is a polyatomic ion with a charge of -1. So what that means is that copper needs to have a charge of +1. What I also know, based on the periodic table, is that copper is a transition metal and it's multivalent. So I need to specify its charge. I'm going to write copper 1 nitrate. Okay. What about this third one? I'm looking at an NH4. Okay, and then we have a chlorine. Chlorine definitely has a charge of -1. And this looks like a polyatomic ion, and it's this one right here. This is a very special one. It's called ammonium, and it's actually got a positive charge on it. Therefore, it can act as kind of the metal in an ionic compound. But naming conventions stay the same. This is ammonium chloride. Just writing the names down with an "ide" ending on our nonmetal. Last one here, we've got a hydrate. Let's look at the first half. That looks like magnesium. And we've got another polyatomic ion. This would be called sulfate. But we still have to deal with all this water over here. And for 7 molecules of water, I believe the prefix would be heptahydrate. Okay, we've done some easy ones, we've done some hard ones, but we are missing a crucial type of compound that's very common in chemistry, and that would be good old acids. So how do we deal with acids in terms of naming them? Well, acids are a little bit strange, right? Because if we look here, I have hydrogen and chlorine, and they're two nonmetals. But if I have a solution of this compound, I'm actually going to have a concentration of hydrogen ions. And that's what makes this compound acidic, right? Because we measure the acidity of something by its pH, and that is simply the concentration of hydrogen ions. So it's kind of got some properties of covalent bonds and ionic bonds. So we're going to name these slightly differently. Following the normal covalent conventions, we would probably say hydrogen monochloride. Or if we wanted to follow the ionic conventions, we would just drop that prefix and write hydrogen chloride. But actually, neither of these are the most appropriate. What we would say is hydrochloric acid. So when we have an acid, we're adding hydro as a prefix to our other element, in this case chlorine, and then we're adding the ic suffix. So if we wanted to follow those rules on this one, we have hydrogen and bromine. I know that's an acid, and I'm going to write hydrobromic acid. Now these simple acids are what they are in the name. They're simple. So hydrochloric acid, hydrobromic acid, hydroiodic acid, which would be HI. Those aren't too bad. Things get a little bit more complicated when we have acids that contain polyatomic ions. In the case of acids with polyatomic ions, we are going to drop this hydro prefix. It's actually going to go away. Let's take a look at our first example. This polyatomic ion is called sulfate. Now, I'm not going to use the hydro prefix, but I am going to use the ic ending. And what I get is sulfuric acid. So when we have anything with a polyatomic ion, you can know right off the bat, we're not using the hydro prefix. Let's do one more example. Down here, another polyatomic ion. This is a chlorate. And its name would be chloric acid. And it's very important to know the difference between naming a simple acid and an acid with a polyatomic ion, because let's compare these two names, right? If I put the hydro in front of chloric acid, I know I'm dealing with HCl, but if I drop the hydro, I know I'm dealing with this right here, HClO3. Let's look at one more interesting example. We do need to look out for acid imposters. Some people may look at this polyatomic ion right here, HCO3, and think that it's an acid, because if we would write it out like this, without the charge, it would be, and we could call it carbonic acid, because we have the carbonate ion. However, since we have an overall charge of -1, this is actually its own polyatomic ion, and it's called a bicarbonate. So just watch out for that. All right, just one more list of rules to go. Hope you're still with me. Now, this is all about oxygen and what happens when the amount of oxygen in a polyatomic ion changes. I'm going to get right into the example and then kind of show you how I'm getting the different names. Let's focus on ionic compounds first. Here I have a sodium nitrate. You might remember it from before when we were talking about polyatomic ions. Sometimes the nitrate ion will gain an extra atom of oxygen, and we'll have something like this. And when this happens, the name of the polyatomic ion actually changes. So here we would say sodium per nitrate. And looking back here, that is our first naming convention. When one oxygen is added to the polyatomic ion, we get this per prefix on the ion. Okay, what if we move on to the second naming convention? We're removing an oxygen, and the suffix of ate turns into ite. Let's write that out. We would have sodium here, and then NO2. So this becomes sodium nitrate. Not too bad. Last one. Sometimes we'll have two oxygens removed, and that's going to look like NaNO. And in this case, we're going to have to add both a prefix and a suffix. It's going to look like sodium hyponitrate. We also have some changes to naming when it comes to acids with polyatomic ions. One more example, we've got a bromate polyatomic ion. So the normal name for this would be bromic acid. But we're going to make things interesting. We're going to add an oxygen to our ion. And based on the first rule here, with one oxygen added, we're adding the per prefix. So per bromic acid. Here's where things get a little bit different. Instead of using the ite suffix for ionic compounds, we're going to be using the us suffix for acids. So that's OUS. So bromic acid becomes bromous acid. The last one, we're going to remove one more oxygen and follow this last rule here. We're adding the hypo prefix and the us suffix. Hypobromous acid. Okay, let me zoom out real quick just to show you all the work we've done. That is quite a lot. Now, don't feel discouraged if, half or even over half of this video kind of went over your head. You can come back to it, look at the areas that you were having trouble with, get better. Okay, thank you for following along with me. I know that was a lot. I'm going to leave these practice questions here for you. Now that we've gone over all of the naming rules, you should have all of the tools to name these 4 chemical compounds. Let's zoom out to see all the work we've done. Quite a bit today. Thank you for watching. I hope this was helpful, and have a great day.